Welcome to lesson 7.3, proving triangles are similar. I remember that some of your favorite lessons were in level 4 where we're proving triangles are congruent, and this is just like that, except we're proving that they're similar. Now take a moment, think about which were the 5 ways to prove that triangles were congruent. Don't forget about hypotenuse leg. Alright, you did it? Cool. There were 5 ways to prove triangles were congruent. But guess what? There are only 3 ways to prove that triangles are similar, which is good for you because that means it's just a little bit easier, huh? The 3 ways are this. 1, we can do angle-angle, or AA. So if we know that 2 angles are congruent in 2 different triangles, then they are similar. Then we could do side-side-side. So if 3 sides are proportional in 2 different triangles, then we know they're similar. And finally, there's side-angle-side. We're going to discuss all 3 of these, but without further ado, let's just get right into it. You with me? Hell yes. Okay, angle-angle similarity. Triangles are similar if 2 angles from one triangle are congruent to 2 angles in another triangle. So if you have 2 congruent sets of angles, you know they are similar. So let's take a look here. Do we have 2 congruent sets of angles? And that is a yes, right? We know B is congruent to Z, so that's 1 set. And we know A is congruent to Y, so that's 2 sets. So that means we have 2 sets of congruent angles, and these 2 triangles must be similar. It's that simple. All right? So then we could say that ABC, triangle ABC, is similar to triangle YZX. YZX. And does that order that I'm writing them matter? Yes, because remember, A has to be congruent to Y, so A is congruent to Y, and B has to be congruent to Z, so B and Z. These are in the same position. So make sure you remember you have to write these in the right order. And what's the reason that they're similar? Well, that's right. We need a reason, because of angle-angle. That's our proof. We proved it through angle-angle. Let's see if we can do the same here. Are the following triangles similar? Well, let's see. Do we have 2 sets of congruent angles? We see that angle A is congruent to angle U, so that's 1 set of congruent angles. And we see that C is congruent to L, so that's 2 sets of congruent angles, and that means yes, these 2 triangles are similar. All right? So we know CAT is similar to LUV. And why? Because of angle-angle. That is our proof. You need to be knowing which way you're doing it. Now, another point, I just want to say this. If you remember from 7.2, triangles are similar if all 3 angles are the same, right? We remember that's one of the properties. Now, why do we only need 2? Well, this might be kind of cool, but look. If we want to find if 2 angles are the same in 2 different triangles, that means the third one has to be the same, right? Because if I want to find the third angle in both of these, what would I do? I would do 180 minus 30 minus 110, and that would give me this angle, which happens to be 40. And for this one, if I did 180, I'm just going to do the same thing, minus 110, and that would also equal 40. So the reason we only need 2 angles is because if 2 angles are congruent, we know all 3 are congruent. Whoa, did I just blow your mind? Yes, I did. But for the big point, you just need 2 angles that are congruent to prove triangles are congruent. Now let's take a look at this guy. All right? Are these 2 triangles similar? Well, we have 1 angle that's the same, right? But these second ones are not. All right, these aren't, so we don't have 2 angles. But wait, we're not done. Maybe these missing angles are congruent. So let's figure out what those missing angles are. And how we're going to do that? Let's do 180 minus 81 minus 60 to find out what that first angle is. So this angle, 180 minus 81 minus 60. Let's see, that'd be 99 minus 60, which would be 39 degrees. All right. And let's do it for this triangle too. 180 minus 81 minus 40. And let's find out what that missing angle is. Let's see, that would be 99 minus 40 would be 59. So are these triangles, do they have two sets of congruent angles? Let's see, 60, 40, 60, 59. No, no, we only have one set of congruent angles. So these two are not similar. All right? I'm just going to write that over there. Not similar. All right? Because they don't have two sets of congruent angles. All right, the second way to prove that triangles are similar is side-side-side similarity. All right? The way we do this is this. If all three pairs of corresponding sides of two triangles have the same ratio, then the two triangles are similar. All right? And the way we could check to see if two triangles are similar, well, we just set up the ratios of each pair of corresponding sides and see if that ratio is the same. All right? So we'll just do it 3 times. So let's start with the biggest side of both triangles. So the biggest side of of our first triangle is YZ. All right? And we're going to put that over the biggest side of our second triangle, which is EF. So the ratio of YZ to EF, our two biggest sides, is 10 to 5, which is just 2 over 1. All right? So that's our first ratio, YZ to EF. Our second ratio is the second biggest side, all right? And that would be, for our first triangle, the bigger triangle would be XY, and for our smaller triangle would be GE. And so the ratio of the second biggest side and our bigger one to the smaller one is 8 to 4, which if we put that in the calculator is the same thing again, it's just 2 over 1. So now we got to check the third side. So we're going to check the shortest side of both triangles. The shortest side of our bigger triangle is XZ, and the shortest side of our smaller triangle is GF. So it's XZ over GF, which would be 4 over 2, which is once again, if we put that in the calculator, just 2 over 1. So if you see here that all three have the same ratio, then we know that our two triangles are similar. So XYZ is similar to GEF. Why? Because of side-side-side similarity. All right, let's try one example of this. Okay, we'll just do one example of this. So determine if the following triangles are similar. If so, write a congruent statement and why. So let's try this, okay? So we're going to start by setting up our ratios, okay? We'll start by doing the biggest side of both triangles. So the biggest side of this triangle is BC, all right? So we got BC over here. The biggest side of our second triangle is 12, all right? Is FE. So we're going to do BC over FE, which is 16 over 12. We put that in the calculator, and what we get is 4/3. Okay? That's our first ratio. Now the second biggest side of this triangle would be AB, right? The second biggest side of our second triangle would be DF. AB over DF would be the same as 12 over 9. And this ratio would be, well, let's see, 4/3. All right, looking good so far. We got two that are the same. So let's do our smallest side now. All right. Our smallest side of this one is CA or AC. Okay, and the smallest one of this one is 6. ED. AC over ED would be 8 over 6, and if you reduce that by putting in the calculator, once again you get 4/3. And look at that, the ratio of all three is the same, so these two are similar because they're all the same. So A, B, C is similar to D, F, E because of side-side-side similarity. So to prove that two triangles are similar by side-side-side, all you have to do is find the ratio of all three sides. And if the ratio is the same, then you know they're similar. And remember, you got to do the biggest with the biggest, second biggest with the second biggest, and the smallest with the smallest in both triangles. Finally, side angle side. All right? If two sides in one triangle are proportional to two sides in another triangle, and the included angle in both triangles are congruent, then the two triangles are similar. So, to start off with, it does have to be side angle side. You have to have an angle between two sides in both of them. So that's your first check, okay? So in this one, ABC, we have an angle that's between two sides, side, angle, side. In this one, side, angle, side. But that's not enough. We have to check first that the two angles are congruent, right? So B and Z, well, they're both 90 degrees, so B is congruent to Z. All right, so our angles are congruent. And now we have to check that the sides have the same ratio, all right? So let's check that out. So first let's start with the bigger side of both triangles. The bigger side of our first triangle is BC, all right? And the bigger side of our other triangle is YZ. BC over YZ would be 36 over 24, which reduces to 3 halves. Okay? Now our second one would be BA. This is our smaller side. And this one would be XZ. All right? That's our smaller side. BA over XZ is 15 over 10, which reduces to 3 over 2. So let's see, the ratio of the two sides are the same, and we have two angles that are congruent. So this is side, angle, side. All right? So we would say BCA is the same as ZYX because of side, angle, side. Let's try just two examples of this. Are these pairs of triangles similar? If so, write a congruent statement and why. Okay, well, looking at this, let's see. We have two sets of sides, right? We have to check to see if they're similar. But we're missing an angle, right? To do side, angle, side, we need an angle that's congruent. But don't forget, vertical angles are congruent. You can always mark vertical angles. So look at that. Because these are vertical, let's mark these. Okay? So we do have angles that are congruent. Now we just have to check to see if the sides have the same ratio. Okay? So let's try that. Let's start here. We're going to do the biggest side of our first triangle, which would be EB. Right? That's our bigger side. So EB. And the biggest side of our second triangle is BC. EB over BC would be 36 over 24. And we just did that. That's the same thing as 3 over 2. We found out that we have two congruent angles. The two congruent angles are ABE. Remember, we got to use 3 to name that. ABE is our first angle. And that's congruent to CBD. All right, so we have a congruent angle now. Now finally, we have to see if the shorter side has the same ratio. So the shorter side in our first triangle is AB. Shorter side in the second one is BD. AB over BD is 27 over 18. If we put this in the calculator, sure enough, we get 3 over 2. So these two triangles are similar because our two sides have the same ratio and we have one angle in between that's congruent. So we know ABE is similar to DBC because of side, side. So why did I write side, side, side? Because of side, angle, side. Finally, are these pairs of triangles similar? If so, write a congruent statement. And I'll tell you this, just looking at this, I could tell you no. All right? Now, why no? All right? Because look, if I did 6 to 3, right, let's try our first side, right? That gives me 2. And I did 8 to 4. That also gives me 2. And look at that, I have one angle that's similar. I mean, that's congruent in both of them. So shouldn't this be side, angle, side? And the answer is no. Because remember, the angle always has to be between these two sides. It has to be side, angle, side. In this case, it's angle, side, side, right? Because the angle is in between the two sides, so these two are not similar. Wah, wah, wah. Okay, that's it for this lesson, guys. Remember, Do not look a rabid beast in the eyes because it will bite your face off. Fact.